Interpolating surfaces with slope. So recall this is exercise E that we are looking at. I did change it a little bit. I removed the section line so it wasn't visually annoying. So it is pretty much the same as the previous exercise, just remove the section line. So before it looked like this, and I just took that out. So kind of a recap of what we've done so far. We have spent some time figuring out grading with slope constraint by hand with paper and pencil. So we use this exercise to kind of figure out how to do that. So the next thing that we'll need to do is we need to actually apply this to Civil 3D. So basically do what we've done here, but we do it in Civil 3D. So oftentimes we're doing this by hand. We usually print out the base map and roll a sheet of trace on top and then kind of, give us a rough idea of how the grading is going to work. And we usually do it with the major contours, and then when we bring it into Civil 3D, we'll do it with the minor contours. So recall the most common reasons for needing to grade is to conform with some type of slope requirement or some type of slope constraint. So you're probably wondering, what exactly are some of the slope constraints? So I have created this table here that allows us to see what some of those slope constraints might be. So for example, we have planted areas here, and we have different types of areas such as lawn, grass, berm, mowed slopes, unmowed grass slopes, and shrub only slopes, and then what those preferred or minimum maximum range slopes might be. So if you go down here to the lower right, this is kind of our legend. So the black color is preferred slope range, and the gray color is minimum maximum slope range. So let's just take a look at the very first one here, long grass area. And we notice that the black part of it, bar, starts here and it goes all the way over here, and then we have some gray ones. Looks like we have 5 gray cells and 1 gray cell over here. So this very far left one, you can kind of think of this as like the minimum slope range, and all these gray ones here is the max. But the preferred is within this black area here. So knowing that this is your preferred area for your lawn, exactly what slope range should that be? So if we take a look up here, we have something here that says gradient, and this is going to be our rise over run, or our vertical divided by the horizontal, which equals a percentage. These are percent values. So here it starts at 1.5% slope to a 10% slope. So this is recommended for grass lawn areas. We also have some numbers up here at the top. So recall that you may be working with contractors or engineers, and they use kind of different ways of referencing slope. So we have vertical inches per foot linear feet. So this is inches feet. So sometimes you may see it referred to as this. Sometimes there's a ratio. So remember that ratio, it's horizontal and vertical. So here's some of those ratio values here in the very bottom row of the top part of this table. And then we saw that slope range, which was given to us in degrees, and that's this middle row here. So this is a great way to just say, well, I need to grade something at a lawn, and I'm going to choose 5%. So that's right here, 5%. I know I want it to be here in the middle. So the most optimal range is 5%. If I need to communicate this to a contractor, I'm going to tell them it's going to be a 20-to-1 slope, or if an engineer or someone else, 2.86 degrees from the horizon. So this is our slope table. So we have some other ones here. We have swells and drainage areas. So we can see that it prefers a 2% slope. We also have some paved surfaces. So unimproved roads, 2.5%. Improved street crown. So this is a street with a crown. So recall that streets are those kind of driveways that have kind of a ditch, not a ditch, but kind of like a curb on each side. And then roads are those things that do not have a curb, they have a ditch instead. So that's the difference between a road and a street. So this is with a crown, and this is just with a gradient. So this is where if the street was flat, you need to produce a crown so that the water would flow off to each side into the curb. And this is where maybe if you're going down a hill and there's a street and you need to provide a gradient. So here's the optimal slope ranges for that. So for a flat street, it's about 2% slope. So this is cross slope. So from the center of the crown, kind of draining off to the side of the ditch or not the ditch, the curb, sorry, you need to maintain a 2% slope there. Alright, so let's go back to our example over here. And one of the things that we need to do is kind of outline some of the steps of how to grade with a slope constraint.